Hello students, welcome to YourPedia platform. I am Rohit Singh, your mentor, and today I am going to be discussing a question from NPTEL Assignment Booklet series of subject Open Channel Flow, which is given on page number 238 as question number 22. So here in this question, they have given you a rectangular channel of width 2.4 meters carrying a discharge of 7 Qmax with a depth of flow as 1.5 meters. And they are saying that there is a hump or the rise in the level of the bed of 0.15 meter during the flow of the channel, right? So, and they are asking you to calculate the depths after the hump, right? So, this would be the channel section. There will be a hump or the rise of 0.15 meter, and I have assumed a section 11 before the hump. This is section 11, and a section after the hump as section 22, and the depth of flow at section 11 will be y1 and the depth of flow at section 22 will be y2, as well as the energy is in the same way, E1 at section 11, E2 at section 22, right? So before starting this question, they have also given you discharge. So discharge is 7 meter cube per second, right? So we can easily calculate the velocity of flow, right, which will be equal to discharge upon area at section 11, right? So area at section 11 will be equal to by1, basically length into width, which is, or depth into width, right? So width is 2.4 meters and depth of flow is 1.5 meters. So this will be meter square of area at section 11. So we can easily find the velocity at section 11 as q upon or discharge upon area at section 11, right? So this will be equal to 7, which is q upon 2.4 into 1.5 meter square, right? So this will come out to be velocity v1 as 1.944 meter per second, right? Now we can also similarly say that the area at section 22, so basically at area at this section will be equal to width of the channel into depth at this section, which is y2, right? So similarly area at section 22 will be equal to 2.4 times y2 meter square, right? After this, what we need to do is we need to calculate the Froude number in order to tell that the flow is in subcritical, supercritical, critical state. So because we know that if the flow is in subcritical state before the hump, then even after the hump the flow will be also in supercritical, subcritical states respectively, right? So flow remains in the same nature, right? So when we calculate Froude number, we know that Froude number is equal to V upon root GAY by T, where A is area of cross section, V is velocity of flow, and T is top width. And since this is a rectangular channel, so basically top width will be equal to width itself, right? So top width T will be equal to B will be equal to 2.4 meter, right? So in this way we can say that Froude number will be equal to V1 upon root G, area will be by1 divided by B, so B and B cancelled, so the Froude number becomes equal to V1 upon root G by 1, right? Now we just need to substitute the values of V1 and Y1, and since we have also calculated value of V1, which is 1.944 meter per second, so we just need to substitute V1 as 1.944 meter per second upon root G. G is 9.81, we all know that acceleration due to gravity is 9.81, right? Into depth of flow at section Y1. Basically we are calculating Froude number at section Y1, and whatever the nature of flow comes at section 11 will remain same at the section 22 as well, because the nature of flow doesn't changes, right? So from this we are getting the Froude number as 0.413, and since this Froude number is less than 1, so we know that the flow will be in subcritical state, and from this we can also say that at section 22 also the flow will be in subcritical state, right? So since Froude number is less than 1, flow is subcritical, right? Now we can also calculate that the area or the energy at 11 will be equal to specific energy at 11 will be equal to y1 plus v1 square by 2g. This is basically specific energy at section 11 at 11, right? So from this we know y1, which is 1.5 meter, v1 also we know, which is 1.944 meter per second, and g also we know. So we can easily find the specific energy at section 11 as well, right? So from this, and when we substitute the values, then we will get the E1 value as 1.6927 meters, right? So this is basically the specific energy at section 11. Similarly, we can also calculate the specific energy at section 22, right? But we don't know the depth of flow at section 22. So we will assume that the depth of flow at section 22 is Y2, right? We just need to substitute the values. So specific energy at section 22 will be equal to Y2 plus V2 square by 2G, right? And V is basically velocity at section 22. So V2 is basically velocity at section 22. So velocity at section 22 will be equal to discharge upon area at section 22, and discharge remains constant in the open channel flow, right? So discharge will be 7 qmax upon area at this section will be B, or the width, into depth of flow, which is Y2, right? So in this way we can get the velocity as 7 upon B is 2.4 times Y2, right? So this will be the velocity at section 22. Now we just to replace this value in the specific energy at section 22. So this will be equal to, E2 will be equal to Y2 plus Q square upon A square into 2G, which is velocity only, right? V square by 2G. From this we will get the E2 as, E2 will be equal to Y2 plus 0.4335 Y2 square times 0.4335. So E2 will be equal to Y2 plus 0.4335 upon Y2 square, right? So after this, the main concept comes in this question. Basically what will be happening is, if there is no head losses or the hydraulic head losses in the channel, then energy at section 11, or the total energy at section 11, will be equal to total energy at section 22. Now come back to our diagram. So basically, so this is the energy at section 11. Similarly, the energy at section 22, or the total energy at section 22, will be this much, and these will be equal, but the specific energy will be equal to E2, which is this value. So we can say that E1 plus E1 minus delta Z will be equal to E2. Is it clear? And this was the main concept of this problem, right? So we can say that E1 minus delta Z will be equal to E2, and we know the value of E1 as 1.6927, which we have solved earlier here. So E1 is so which we have solved earlier. So E1 is 1.6927 meters, right? So we can say that E1 is 1.6927, and delta Z, which is the rise in the bed level or the hump, is given as 0.15 meters, will be equal to Y2 plus 0.4335 divided by Y2 square, right? Which is the specific energy at section 22. From this we will get a cubic equation in Y2. Basically, cubic equation shows that there will be 3 values of the depth of flow at section Y2, right? So this is the cubic equation in Y2. So we will be getting 3 values of Y2 at section 22, right? So Y2 comes out to be, when you solve this equation, you will get the Y2 values as 1.277 meter, 0.9441 meter, and a negative value as well, which is minus 0.1255 meter. And we know that the depth can't be negative, so this value we can't take, right? So we are left with 2 above values, right? And from this we can we will choose on the basis of that since the flow was subcritical, and when the flow is subcritical we choose the larger depth, right? So we will adopt larger value of Y2 since Froude number is less than 1 or subcritical flow, right? So which is larger value among the top 2 values? This will be 1.277 meters, right? So now we have also calculated the depth of flow at section 22, right? So we can say that the Y2 will be 1.277 meter, and in this question they have asked you to find the change of water surface elevation. Basically they are asking you to calculate this much change in water surface, this much change in water surface elevation, right? This is delta. This is they are asking in the question, right? And this will be equal to, so basically change of water surface elevation will be equal to depth of flow at section 11 minus depth of flow at section 22. So whatever the depth is decreased while traveling from section 11 to 22, this will be equal to the change in water surface elevation. And this is happening because of the hump present in the channel. So this will be equal to 1.5 minus 1.277, and this will come out to be 0.223 meters, right? So this is the first part of the question. This is the answer to the first part of the question. So basically the water surface will drop by 0.223 meters while traveling through the hump of height 0.15 meters through the channel. After this, they are also asking you to calculate what will the maximum rise in bed elevation if the upstream depth is not affected. Now there comes a concept of choking, right? Basically what happens is whenever there is less and whenever the energy at section 22 is less than the critical energy at section 22, then there will be a condition that there will be choking in the channel, right? What choking is? Basically when the choking occurs, the depth of flow at the upstream end changes and the downstream depth becomes critical, right? So from this we can say that now upstream depth changes when energy at section 22 is less than critical energy at section 22, and this is basically the choking condition, right? Now they are asking you to calculate the maximum rise. So when the energy at section 22 becomes just critical or critical energy, right, then you will get the maximum rise in the bed elevation, right? And because after that the y1 starts changing, and in this question they are asking you that the upstream depth doesn't change. So the upstream depth won't change till the energy at section 22 is greater than or equal to critical energy at section 22, right? So we can say that E2, which is the energy at section 22, will be equal to critical energy at section 22 to get maximum rise in bed elevation, right, such that the upstream depth is not affected, right? So till energy at 22 is equal to critical energy at section 22, the upstream depth won't change, right? So we can say that first, so we should also find the critical energy or critical depth at section 22, right? And this will be equal to q square by g raised to power 1 by 3. So basically critical depth will be equal to q square by g raised to power 1 by 3, right? Where small q is discharge per unit width, right? So just substitute the values. So yc will be equal to q by b whole square upon g raised to power 1 by 3, and this will be equal to q is 7 qmax, which was given in the question, and width is 2.4 meter raised to whole square upon 9.81 raised to power 1 by 3, and from this we will get the critical depth as 0.9536 meter. So our critical depth is 0.9536 meter. So till this depth of flow the upstream depth won't change, right? So after this we can say that rise in bed elevation will be equal to E1 minus YC. Basically E1 was the energy at section 11 minus critical depth at section 22 will be equal to the rise or the maximum rise in bed level, right? So this will be equal to 1.6927 minus 0.9536 meters, right? So from this we can conclude our question as rise in bed elevation without affecting upstream depth. Basically till this depth the upstream velocity or the upstream depth of flow won't change. So rise in bed elevation without affecting upstream depth will be equal to 0.7391 meters or 0.74 meters, right? So this was the whole question. So I hope you understood. Keep preparing. Have a nice day. Thank you.